Okay, so continuing with our look at quadratics, today we're looking at multiplying polynomials, and there are actually a few properties and mechanics we have to examine. So we remember the distributive property allows us to basically skip the b in BEDMAS. So if we were asked to simplify something like this, we know we could do BEDMAS because we can work out 2 plus 3, which is easy. We know 2 plus 3 is 5, and we know 4 times 5 is 20. We know the distributive property tells us that we're also allowed to do the 4 times 2, which is 8, and then do the 4 times 3, which is 12. And of course, when we add those two things together, 8 plus 12, we get 20. So we get the same answer both ways. The distributive property will give us the same answer. The thing is, we use the distributive property when we can't add these two things together. So the general rule here, of course, is a times b, which is ab, and then a times c, which is ac. Now we use this distributive property when we do not have what we call like terms in the bracket. So for example, here we see we have 4x and 2y. We can't add those together. So if we were to go through BEDMAS, we would be stuck on the b of BEDMAS. They can't go together. However, we know the distributive property will give us the same answer anyway. So I can go 2 times 4x, which is 8x, and I can go 2 times 2y, which is 4y. So I can get around the bracket part. Another example here, if I have a 3 out front, I can do 3 times 7a, 21a, and 3 times 6b, 18b. So the question now, of course, is what if the first thing we're multiplying by is a binomial? What if this isn't a number 3? What if this is also a binomial with brackets and two terms? And I'll give you a hint. The reason why we ask that question is because it pops up in quadratics. So let's take a look, and we're going to try looking at a couple numbers here first. So suppose we have 4 plus 3 and 1 plus 5. Our first method will be to solve using BEDMAS. So I'll simplify the brackets first. I know 4 plus 3 is 7. I know 1 plus 5 is 6. I know 7 times 6 is 42. That's great. Now we can also get 42 by using what we call the double distributive property. So that'll be method 2. We'll solve using this double distributive property. So I'm going to go 3 times 1, which is 3, and 3 times 5, which is 15. So I'm going to distribute this 3 through, and then I'm going to distribute the 4 through. 4 times 1 is 4, and 4 times 5 is 20. So I've done the distributive property twice. I've distributed the 3 through and distributed the 4 through. Now, of course, when I add those four numbers together, I also get 42. I get the same answer. Now, when do we use this method? It's the same idea. When we cannot simplify the brackets first, that's when there are unlike terms involved in the brackets. Now, there's actually an acronym that's going to help us remember this double distributive property. And that acronym is FOIL. And here's what it stands for. If I have the product of two binomials, the F stands for first. I multiply the first things together, so AC. The O stands for outside. I multiply the outside terms, so AD. The I stands for inside. I multiply the inside terms. And the L stands for last. I multiply the last terms. It's really the same thing. It's the double distributive property, right? I'm going A times C, there it is. A times D, there it is. B times C, there it is. And B times D, there it is. Here's a quick illustration of that. Outer or outside, the inside terms, and the last. So next example here, 2x plus 7 times 4x plus 2. I'm going to multiply the first, so 2x times 4x, 8x squared. I'm going to multiply the outsides, so 2 times 2x is 4x. I'm going to multiply the insides, 7 times 4x, 28x. And I'm going to multiply the last. 7 times 2 is 14. Now if I look at that expression, I notice that the inner two terms are like terms. The 4x and the 28x, they can be added together. So when I do that, I get 8x squared plus 32x plus 14. And look what we get. This is the quadratic model. When we multiply two binomials together, we actually create a quadratic. That just happened. I know, it's pretty impressive. We see that this multiplication actually creates this model for us, which is actually very interesting. So that's the reason why we're studying FOIL now, because we can see how it ties into our quadratics. Another example, I could FOIL these. X times x is x squared, 2x, negative 4x, and negative 8. And then again, I would add the inner two terms together to get my final answer, which of course is also a quadratic. If there is a number out front, then we can FOIL the first then distributive property. So for example here, I have 2, then bracket x plus 9 and 5x minus 3. What I can do is I'll just leave the 2 up front. I'll go x times 5x, 5x squared, negative 3 times x, 45x minus 27. Add my inner terms together, and then I'll multiply by the 2. So then I'll go 2 times 5, 2 times 42, and 2 times 27, and that will give me my final answer. We can do a little bit of geometry with these questions just for practice. If suppose you're asked to find the area of a rectangle, okay, I know the formula for area is length times width, so I would just do the top part here, which is the length, and the side part here, which is the width. I would multiply them together. I would FOIL them out and collect my like terms and get my final area. I think it'd be a little more complicated. I could say write an expression for the shaded area, and I know the area that's shaded would be just the big area here, take away the little area there. So area of the big, take away area of the small, and that would be area of the shaded region. I would build my length times width for the big, x plus 5 times 2x plus 7, which is there, and then the small one, x plus 3 and x plus 2, which is there. Okay, we're going to stop there, and we'll watch part 2 of this video right after.